Welcome to all. See, first of all, make a note. This is extension for class number part 7. That is last part uploaded. So this is actually today is part 8. I think number is correct most probably. Yes, part 7. Some concept oriented. Extension of part 7 means which example we solved in part 7, same example you are considering. Remember. So before you go through this class, you have to first to go to that class. Correctly understand. Suppose you don't go to that class and come to this class. People will tell, I can't make out anything. Okay, don't make out anything. If you are not following what I told, I am helpless. So, I will tell once again. Last class, we solved a question. That was doubly reinforced section, stress calculation. Roman 1. Roman 2 is meant for MR coming up in further classes. Question was, a rectangular section of a RC beam, 250 mm wide and 650 mm deep, is subjected to sagging BM of 125 kilonewton meter. I remember it. 125 sagging BM. Then, beam is reinforced on tension side by 3 bars of 20 mm diameter and on compression side by 3 bars of 16 mm diameter. For tension side, clear cover given was, I remember, 45. Compression side clear cover given was 40. And in the question, M is given as 11. Question was, find stresses developed in concrete, that is understood, maximum compressive stress developed in concrete, and also stresses developed in both the steel, in tension steel and also ASC. I won't write all these things. Already solved. See, now, B, D, A, T, A, C, D dash, M, D dash means what? From extreme fiber to center of compression steel. M11, therefore MC 16.5. This all told last time. MC equal to 1.5 M. Now, how we solved last time? We used, right here, see, class. We used expression for M in terms of compression. At that time I told, everywhere people will tell, in terms of tension, you cannot use the expression. Actually, it is not that you cannot use, but it is lengthy. See, singly reinforced section, we can use either M in terms of compression or in terms of tension. In limit state also same thing. Here, compression equation, singly reinforced. M equal to Bx FCBC by 2 D minus X by 3 over. If you got tension, M equal to AST FST into D minus X by 3. So, to get FCBC, stress in concrete, substitute M, get FCBC. Singly reinforced. Actually, once you get FCBC, you can use the relation. Where is the relation? MFCBC by FST equal to X by D minus X and get FST. Or FCBC, concrete compressive stress, you can find based on compression equation. And tensile stress, you can find based on tension equation. That all we discussed earlier. But that is in singly reinforced section. In doubly reinforced section, derived equation is only one. See now, doubly, extra terms are there. MC minus 1 ASC, FC dash into D minus D dash. What is FC dash? All over. See, that FC dash we got in terms of FC by what? FC dash divided by X minus D dash equal to FCBC by X. We got FC dash 0.708 FCBC. This all you had referred last time class. Okay, now, why I am taking this class is, so many people will tell, I heard it in online class also, for both working test method and also limit state method, doubly reinforced section, expression is available only in terms of C. No expression possible in terms of T. I will tell why they are telling that way. Okay. Now, time being, for some time, leave this one. Go to basic derivation. Remember, in my regular batch, I did the basic derivation. So, if you know the basic concept, you will understand. Or you just go through it. ASC, etc. Stress distribution diagram like this. Then stress distribution diagram across cross section for equivalent concrete area. Now, from here to here, compression. Stress variation is FCBC here, 0 here, linear variation. Therefore, because of this compressive stress here, this concrete area in compression, that is B into X. B into X is the area of concrete in compression. Stress is FCBC here, 0 here. So average stress is FCBC plus 0 by 2 or FCBC by 2. This area into stress will give the force. This will give the force C1. See, this all told for you earlier in the class. So those who are not in the group, if you understand, okay, for this purpose, I cannot go to derivation now. And you see what is the concept involved now, over. This is acting at where, because it is uniformly varying here, triangle, the resultant force will act at 1 through CG of the stress diagram, 1/3 of X, X by 3. If this is X by 3, see, C1 is, remember, you should write here, compression force in concrete. Resultant compression force in concrete. First of all, I should not give. Okay. This is acting at where? Line of action is at X by 3 from the extreme compression edge. That's all for singly. And if that is X by 3, this will become D minus X by 3. That's how singly you got C into lever arm, see, BX FC by 2, FCBC by 2 into D minus X by 3, expression for M. But W in post section, there is one more compression, that is C2. Compression force in ASC. Compression force in ASC, compression steel. This is equal to area of the steel, first area of steel. ASC is the area of steel. You have to convert to concrete, that is MC, but minus 1 is there. Minus 1 reason I told very thoroughly in the class, not YouTube class, for the regular batch. Others you have to accept what I tell, you have to agree. MC minus 1 into ASC. Now this will become equivalent concrete area into, at this point, stress is FC dash into FC dash. That will give you the resultant force C2. That will act at D dash from here. Okay, now, and total compression force, C, resultant, considering both, will, see, this is a resultant compression force for cross section equal to C1 plus C2. And your tension force T equal to area of steel in tension, AST. It is M times AST, equivalent area into stress is FST by M. Or simply, your T will be equal to, this is C, FST into AST. Or which one first actually? BX, okay. AST into FST, because area first, okay. AST into FST. That will act here. Now, problem is, see, in singly in post section, one compression force C, one tension force T. Lever arm is D minus X by 3. So, to find internal resisting moment, if you take moment about this point, you will get C into D minus X by 3. That will come BX FCBC by 2 into D minus X by 3. Don't see here. And that all we used in the singly. You go through part 1, part 2, part 3, part 4, part 5, etc. Or you can take moment about this point. Then T into D minus X by 3. That will give you AST FST into D minus X by 3. This all we used in singly in post section. But now there is a problem. What is the problem is, 1 minute here. I don't know where that rubbing one. Yes, right time I won't get it. I don't know where I kept it. Okay. Now I got it. Okay. Now but this is for singly. Doubly problem is, there is one force C1 here, and little side. There is I am saying W in post section now. One force C1 here, little upper side, we got another force C2. and tension force is T here. Here, this distance is, see, for C1, see here, you can see here, C1 distance is D minus x by 3. C2 distance is D minus D dash, lever arm. Now, it, like in singly, I told you to get the expression for M, you can take moment about either line of action of resultant compression force or resultant tension force. Now, one problem, the resultant compression force will pass where? Somewhere here in between. This is resultant compression force C equal to C1 plus C2. Tension will act here only. So for that one, a new lever arm called A. Lever arm called A. Now, we do not know where is this C resultant passes. Why? C1, C2, two forces are there. So resultant will pass somewhere in between. To avoid that confusion, see, so if you want to find the expression for M in terms of T, you are right, M equal to T into that lever arm. Oh, problem. Why? That lever arm difficult to find. Therefore, what people do is, everywhere, you write M equal to C into A. See, C into A means this C into A. Now there is no problem because moment of resultant C about this point, C into A equal to your C1 into D minus x by 3 plus C2 into D minus D dash. That is called Verigno's theorem. Alt moment of the resultant about any point in the plane equal to algebraic sum of moments of the individual or component forces. So, you cannot, it is difficult to take moment about line of action of C because first of all, you are not knowing where is the line of action. So what people do, they take moment about this line. Then also same thing, it is C into A. But C into A equal to, see I write here, that C into A will be equal to C1 into, I will call this as A1, this I will call A2, C1 into A1 plus C2 into A2 by Verigno's theorem. That's how we got M equal to C1 Bx FCBC by 2 into D minus x by 3, C, C1 A1 plus C2 MC minus 1 ASC into FC dash into A2 D minus D dash. This is the general argument. People will tell that line of action of what? Resultant compression is difficult to locate. So you cannot take moment about line of action of compression. Take moment about line of action of tension. Your M equation will come in terms of C. See, like it came based on compression. And they will tell, so many will tell, it is not possible to get expression for M in terms of tension. No, they are wrong. Now I will do one thing. See, already using this equation, we got FCBC, FSD, all we got last time. See, last time class, we solved this way. Now I will show you why people are wrong. See, there is no impossible. If you know the concept, you can solve anyway. But remember, actually, writing expression for M in terms of what? Compression is easier. Writing expression for M in terms of tension means you take moment about this point. It is lengthy one. I told you. You stop eating like this. You eat like this. But remember, you can eat like this. See, if you got a spoon, you can eat like this. But remember, you can eat like this. Don't tell impossible. I will prove it is possible. But later, don't go for it. Because why? Unnecessary complication. That should be avoided. You people should not go for unnecessary complication. Okay, now. But still, only for what? Understanding principle, I will tell. Okay, now. 1 minute now. See, remember now, C1 equal to Bx FCBC by 2. I am rubbing everything. C2 equal to MC minus 1 ASC into FC dash. That's all I want. And remember, C1 is acting from the extreme compression edge at x by 3. C2 is acting at D dash. I am removing all this now. Y means I want new sketches. You should not ask later, how you got? See here, C1 acting here, C2 acting here. How much C1, how much C2? I wrote here. Okay, now, what I will do is, I will go for, no, I will remove this one. Because why? You can take a screenshot of that one and note down. Now, see what happens. Suppose, right here, suppose somebody like me, for people like me, wants to write the expression for M in terms of tension. He has to write T into that red color A. See, that red color A. I told you red color A. What to do then is, you consider C1, see, what you do? Then A is actual lever arm. Lever arm. That is distance from line of action of tension force T, perpendicular distance, okay, or distance between. You can tell distance instead of from, you can tell distance between, okay, between line of action of resultant tension force T and that distance means perpendicular distance. I won't waste time on all those things which are actually known to you. No point in wasting time. You write here, it is lever arm is distance between line of action of resultant tension force T and line of action of resultant compression force C. C is the resultant of C1 and C2. For that, what you do is, okay, now, so therefore, finally, you will get a single force C here. T is already here. T is here. This T equal to AST into FST. This is a new lever arm, A. So now if you take moment about this point, M equal to T into A. So T equal to, remember, AST into FST. I won't waste time once again. Now you require A. Okay, I will go for A. To find A, what to do is, to find A, I will remove everything now, not required. Now don't waste time on, don't worry about unnecessary things. To find A, okay. Now, to find A, to find that lever arm A, which is distance from here to resultant of these two, actual lever arm. There is only one lever arm. What you do is, consider C1 and C2. This is your C1, somewhere here is C2. Or 1 minute, instead of that way, better make more clear. Consider extreme compression edge. Idu extreme compression edge, top of the beam. From that, or dotted line I will put. Extreme compression edge, dotted line. You come down by x by 3. You get one force, C1. This distance is x by 3. Come down by d dash. You get C2, that is distance d dash. So what you do is, now for these two, you write somewhere here, resultant is here, C. Remember, from here, let it be y bar. So, that y bar means what? Right here, y bar is distance of line of action of resultant of C1 and C2 equal to, formula is, see, actually, basic formula, in mechanics you write, if two forces are P and distance is y, P1 y1 plus P2 y2 divided by P1 plus P2 or total P. Here equal to P1, this C1 force. So it is C1 into x by 3 plus C2 into d dash divided by C1 plus C2. Use this equation, use this to get y bar. Use get y bar. Once you get y bar, you got resultant compression here. Resultant tension is only one force. Tension here. Extreme edge. This is y bar. See, from the extreme compression edge, this is y bar, then your lever arm equal to the new lever arm A equal to from center here to extreme edge is d minus y bar. Then you write your expression for m equal to, take moment about this point. It is t into y bar, that will give the answer. Y bar is here. This is solution by alternate, but unnecessary complications. I am telling only for those, so many people will tell it is not possible. See, there is nothing impossible here. In structure engineering, impossible word is not there. If solution is there, it can be solved. Okay, now, that's all. I will remove everything now. I will continue this question. I don't know where I kept that. Rubbing one. Here. No, not here. Just a minute. Usual problem. Sometimes it gets misplaced here. Somewhere I kept it here just now. Okay, these things happen. Nothing can be done here. See? I want that one. Right time not getting it. That rubbing is easier. Okay, done. Now, this all I will remove now. I will solve this question now with a new concept. See how frustrating it is that one which I used for rub, somewhere I got misplaced it. Just 1 minute. I want to clean, otherwise problem it is. Just. Okay, I will start. Actually, I lost that one. You don't know how much I was angry, got frustrated. It was somewhere here. Okay, now I got it. Okay, now start. Now, come back and continue our question. We will, right here, we will not use this equation. We will use, let us first find FST based on or by using expression for m in terms of tension. That is m equal to AST into FST into d minus y bar. Oh, y bar. Where, red color, see, where y bar is distance of line of action of resultant compression force from extreme compression edge. For that, first to consider the extreme compression edge. Extreme compression edge, that is the top edge of the beam. Here, sagging beam. One force comes, little down. Okay. One force comes here, that is your C1, and another force comes here, C2. C1 is acting at x by 3 from there. C2 is acting at d dash. Because of these two, resultant will pass here C at distance of y bar, and somewhere here tension T is there. This is, see, if I project this one from T, this is the real lever arm A. Now you can make out lever arm A. Now you can make out why it is d minus y bar. From here to here is d. This is your d. So lever arm equal to d minus y bar. Start. Y bar equal to C1 y1 plus C2 y2 divided by C1 plus C2. C1, this compression force, Bx Fc by 2 into y1, this distance, x by 3 plus C2 mc minus 1 into ASC into Fc dash into, this is your C2, okay, this is your C2, into y2 is d dash divided by bx fc by 2 plus c1 plus c2 is mc minus 1 asc into fc dash. See, p1 y1, p2 y2 by p1 plus p2. Now 1 minute now. fc dash, see, you are right. Your fc dash, you have to get in terms of fc. That already you told last time, it will come 0.708 fc. This is same from similar triangles. fcbc divided by x equal to fc dash divided by x minus d dash. I explained last time. Start. Substitute. Substituting b. B is how much? 2 little more space required. I will write here. Therefore, your y bar equal to b. 250 into x. Oh, where is the x value? Oh, I forgot the x value. I noted down somewhere here. 1 minute. X value I forgot. Somewhere in the, I written yesterday, I noted down. X value 100 and, see, usually live class, I usually will ask. I can't find once again x value now. Where is it? Somewhere I written that x value. It's there. 164.358. Sadhya, got it. See, you already got x equal to 164. Paper is there. 358. 358. This you have to get anyway. See, before you start this equation for m in terms of compression tension, first you have to find x. Make a note. X you have to find as usual. Bx square by 2 plus mc minus 1 asc into x minus d dash equal to matd minus x. Okay. Into x. 164.358 bx into fc. Let fc be fc only. You don't know fc. Someone will tell, sir, fc is known. No, don't use the fc. Not fc. fcbc. Oh, this is fcbc. fcbc. fcbc is fcbc only. Because earlier years, I was using fc. Okay, fcbc. fcbc, we don't know it. Because if you use that value, why you want this equation? Instead of finding fcbc first, we find fst first. fcbc, bx fcbc into x by 3. 164 point, yeah, again not, 164.358, 164.358, that is x by 2, no, x by 2, x only, into x by 3, 164.358 divided by 3, because by line of action of force is at x by 3, okay. Bx fcbc by 2, xcbc by 2 is the force into bxc. I forgot right here. I forgot that 2. Otherwise, danger. Okay, I can make out now. See, when I know the stress in concrete linearly varying, by 2 should come into x by 3. Then no space there. Plus mc minus 1. 16.5 minus 1 into asc. Where is asc? 603.19 into fc dash is 0.708 fcbc, use a bracket, this one into d dash 48 divided by only what? These two. 250 into 164.358 into fcbc by 2 plus 16.5 minus 1 into asc is 603.19 into 0.708 fcbc. Now see, fcbc here also, fcbc cancels because numerator has got stress term, denominator got stress term, it comes outside, it will cancel. So solving, you will get y bar equal to, I will get the value now in millimeter. This I have to calculate. Why? Because I have not done the calculation. 1 minute, I will calculate. Where is the numeric x value? I will store in memory first, so that I don't have struggle. Okay. 250 into x into, see, I will not look at the board. 250 into x into fcbc by 2 into bracket 1 by 3 of x plus MC minus 1 into 603.19. Oh, something went wrong there. 603.19 MC minus 1 ASC into FC dash is 0.708 into distance is what? D dash 48 over divided by bracket 250 into X into FCBC by 2. That's all, plus MC minus 1 into ASC 603.19 into 0.708. You will get something came wrong. 1 minute. I think I not used the power there. Just 1 minute. I will calculate once again. 250 into X into 0.5 into bracket FC by 2 into bracket shift store A divided by 3 plus 15.5 into 603.19 into 0.708 into 48 divided by bracket 250 into X into 0.5 plus 15.5 into 603.19 into 0.708. 53.1324. If I forget, so fast. 53 point, I'll use red color. See, when I calculate also, I am not seeing the expression written there because I know how terms will come. When I calculate, I can imagine how the forces will come. 53, forgot, answer equal to 53 point, how much? 53.1, I forgotten. 1324, okay. 53.1324 millimeter, 24. This is the value of millimeter, over. Now see, just a minute. Too much of sweating today. I not put the windows on, okay, because it was raining it earlier. Okay, now, last step now, over. Okay, now, I will close it now. See, this all I will remove now. Over, class over almost. Substituting M 125 10 to the power 6 equal to AST 942.48 into FST into D 595 minus Y bar we got 53.1324. You will first get FST. Actually, someone will tell unnecessary complication. Yes, I am telling only because I told it is possible. There is not impossible. Okay. 125. I should not calculate. I should write the same answer what I got here. Still I am checking because why? If the Y bar is wrong, I can make out now. If Y bar is wrong, I can make out now. 125 10 to the power 6 divided by 942.48 divided by 595 minus 53.1324. I won't see the previous answer. I will first write the answer, then see there. 244.7624 Newton per mm square. Now let me see. Yes, see. 244.7589 approximately can be taken as 244.76. Here also, see, 76. 0.002 error because of rounding off. See, actually it is not 53.1324. It will come furthermore. Y bar is not 0.708. More numbers are there. That is not error. Now, lastly, once you get FST, see, last time we using M for in compression, we got FCBC. Using relation, we got FST. Now reverse. Using M in terms of tension, which you derived in the class, FST got now. To get FCBC, use the equation MFCBC divided by FST equal to X divided by D minus X. Substitute FST equal to whatever you got, 244.7624. You do it. FCBC will come 244.7624 into X divided by bracket 595 minus X divided by 11. 8.4923. 8.4923 Newton per mm square. 8.493 here, 8.4922, 8.4923. Such small decimal errors are not problem. Okay, I will close the class now. I thought I will tell about limit state method also. Okay, maybe I will take one more class. I will tell exclusive because later I may not tell. Limit state I may tell. Even the same problem in limit state. So many people will tell you expression for m for limit state method. mu equal to 0.36 fck into what? b into xu into d minus 0.4 to xu plus fsc into ac d minus d dash. They will tell tension side equation is not there. It is there, but lengthy no doubt. So depending on the time availability, I first thought I will do both, but little time it took. Therefore, I will conclude now. And this is the concept-oriented class for those who are interested in knowing the basic concepts.